Okay, guys, we're going to go over chemical bonding. This is page 10 in your notes. You're going to need a pencil and a highlighter. The first type of bonding that we're going to go over is metallic bonding, okay? Now, this is a little different than ionic or covalent. Metallic compounds do not have set ratios like other compounds, like ionic and covalent, okay? They do not have set ratios. So there's no formula like H2O, that's a covalent compound. Two hydrogens and one oxygen combine in this ratio. Metals do not combine in this way where they have set ratios. So if you see something that says like SNPB, that just means that basically there's some tin and there's some lead, and they have been probably melted down together to form an alloy, but there's not a specific ratio in which a certain number of tin atoms combine with a certain number of lead atoms, okay? So no set ratios. Okay, metallic bonds are formed from the sharing of electrons between metal atoms, okay? And they're called delocalized electrons. I feel like this is like the British way to spell it, delocalized. So the electrons are delocalized. That's how you spell it in America. Okay. Metals, they conduct electricity as solids because of these delocalized electrons. So basically the nuclei are stationary, and the electrons are free flowing along the surface of the metal. That's what it means for them to be delocalized. It means they're not in a specific location. It means that these electrons can move around, okay? And this is what we call the sea of electrons, because the electrons can move like waves on the top of the sea, okay? And because these electrons are so free-flowing along the surface of the metal, that it makes metals very conductive for electricity, okay? Because the electrons can move, okay? Also, because of these delocalized electrons, metals are malleable and ductile. We talked about this before. Malleable means that it can be like bent into shapes and pounded into sheets. Ductile means that it can be stretched into wires, because the atoms can slide past each other without their bonds breaking. Metals are lustrous. That means they're shiny. Lustrous, which means they're shiny, and they're often silver because they absorb and then re-emit light as photons. And I mentioned this before, they readily alloy. So an alloy is when there's two different metals that are melted down and mixed together, okay? Like steel. Steel is an alloy of two different metals, okay? Metals typically have high melting points, okay? They have high melting points due to the strength of their metallic bonds. So the more delocalized electrons there are, the higher the melting point. So transition metals tend to have higher melting points than groups 1, 2, and 3. So it kind of generally melting points increase as you get closer to the middle of the periodic table. Okay, so that's metallic bonding. It's kind of different than ionic and covalent. Okay, ionic compounds are also known as salts. Salt is just a fancy word for ionic compounds. Okay, ionic compounds from a transfer of electrons from one atom to another atom, and it typically goes from a metal to a non-metal, okay, resulting in a cation and an anion. Okay, so a cation is positively charged and anion is negatively charged. Okay, ionic compounds can also form between polyatomic ions, and we'll learn more about polyatomic ions. I know you guys covered them last year, but we'll get more into them later on in the unit. But so either a metal and non-metal, or a metal and a polyatomic ion, or anything that has a polyatomic ion in it is an ionic bond. Okay. Okay, each cation attracts several anions. The anions attract more cations, and so on, resulting in a crystal lattice structure. This is a crystal lattice structure. It's very organized. Okay, they're very organized. Okay, properties. Ionic compounds, they are brittle. They have high melting points, so high melting points for ionic compounds. They conduct electricity when melted or in solution. Okay. So ionic compounds only conduct electricity when they're melted, meaning they're liquid, or they're in solution, meaning they're dissolved in water, so they're aqueous. So if they're liquid or aqueous, they'll conduct electricity. Solid ionic compounds don't conduct electricity, okay? Last one, covalent compounds. Covalent compounds are formed from the sharing sharing of valence electrons between non-metal atoms, okay? So covalent compounds happen between non-metal atoms. Atoms don't transfer electrons because each needs to gain electrons. So nonmetals, they're really close to having an electron configuration that is similar to the noble gases. So if there's two nonmetals that are going to form a bond, they both want to gain electrons. Whereas here, metals tend to want to lose electrons, so they transfer. Whereas nonmetals, they both want to gain electrons, so they're going to share. Okay? They usually have low melting points and don't conduct electricity. Okay, there's two types of covalent bonds, polar and nonpolar. Okay, polar and nonpolar. So polar bonds are the first ones. This is when electrons are shared unequally. Electrons are shared unequally. Okay, so that means somebody's hogging the electrons. Okay, somebody's hogging the electrons. The unequal sharing of electrons creates a partial negative charge, or sometimes called a negative pole, at the side with the largest electronegativity, and a partial positive charge at the opposite side. Polar bonds form when there's a difference in electronegativity, okay? When there's a difference in electronegativity between the two atoms, okay? One atom will hog the electrons. Okay, so remember, if an atom is very electronegative, it's going to hold on to its electrons very closely. So if you have a difference in electronegativity, I'm going to flip over to the back. This is a polar bond, okay? If the difference in electronegativity is great enough, then the one with the higher electronegativity is going to hog the electrons more often than this. It's going to the electrons are going to spend more time with the more electronegative atom. If their electronegativity is so great, like what usually happens between metals and nonmetals, that they won't share at all. They'll just straight up transfer their electrons. But if they're a polar covalent bond where the electronegativity difference is high, but it's not as high as an ionic bond, then you get a polar covalent bond. Now, if the electronegativities are very, very, very similar or equal, it's going to create a non-polar covalent bond, meaning the electrons are going to be shared equally. They're going to be good sharers. That's what I tell my 3-year-old. You need to be a good sharer, okay? So non-polar bonds, these are good sharers. They're shared equally. Okay, any element bonded to itself. So for example, if you have like carbon bonded to carbon or fluorine bonded to fluorine, anything bonded to itself, okay, is going to be a nonpolar bond because their electronegativity is going to be exactly the same. They're going to share the electrons equally. And carbon bonded to hydrogen, that one's also considered nonpolar because these guys, carbon and hydrogen, have similar electronegativities. Electronegativities. That's a really long word. I know. Okay. So that's the difference between polar and nonpolar covalent bonds. All right. Now here's just a summary of all the information we just went over. So ionic this is very important. This will become super duper important when we get into naming. We don't name metallic bonds the same way that we name ionic and covalent, but when we get into nomenclature later in the week, you need to be able to distinguish an ionic from a covalent bond. You need to know that this is a metal and nonmetal, this is two nonmetals, okay? Ionic bonds are transferring, covalent bonds are sharing. You can read through this on your own. It tells you, it kind of summarizes some of those main points, okay? Go ahead and you guys can get started on your assignment.